Okay, so this is the introduction video for week 3 of CST370. And in this video, we will cover 2 parts. One is I'm going to give you an overview of the class so far, including the first assignment. And the second part is to give you an overview of the key topics, the 2 topics that will be part of the week 3. In a couple of days, I plan to make a separate video which will go over some of the labs and programming assignments. So first of all, the quick update on the class. Please welcome to our TA, Roderick. And Roderick is going to start helping this class as a TA. And he's very familiar with this online program. And he also, I think, did the TA for another class before. So he is a very, very helpful resources. And please feel free to reach out to him as well as myself if you have any question. He posted his content and office hours on the island. So this is going to be a great, great help to this class. And the grading for the first week assignments are completed, and the grades are posted to Island. And also, I posted the sample solution as well. So keep in mind that some assignment, particularly the programming assignment, there isn't a single correct solution as long as the results are correct. So there could be many different ways of implementations and so on. But I just post them as one example. And so out of 25 enrolled students we have so far, and for the homework, 23 submitted, for the labs, 22 submitted, and for the programming assignment, we got 21 submissions. I'm very glad to see that for the programming assignments, majority of the submission are actually able to generate the correct output with all types of input streams, some corner cases as well. A few of the implementation kind of worked for some input strings, but failed in other types, some corner cases and so on. In addition, we have 7 video submission. 7 students recorded a video about how they implement it. And I strongly, strongly recommend you to watch these videos and learn from each other, even though some of them may not be 100% correct. If you have any questions about, you can reach out to the students or myself or our new TA, Roderick. And also at the same time, I encourage most students to submit such a video for future programming assignment, because this is a good way of sharing your knowledge with other people, as well as enhancing your learning. As I said, you really don't learn until you actually teach it. Okay. So for the homework, the written question, majority of the issue is around the first one. Only just a few got it completely correct. And so overall, the class is off to a good start. So let me just spend a couple of minutes on the first homework assignment, number 1. And this one is basically giving you a new insert function called insert new. It inserts an element with this data value into a linked list, and the position of the new node is indicated by this parameter called index. So for the first example, this one is going to insert a new element with data value 10, and the position is indicated by this index value to 0. Now, a lot of the students will just think this 0 index is 0, and then just put it at the top of the linked list. But the key is, or the trick is, you need to go through this program in order to find out where exactly is the right position to insert it. And it is really the manipulation of a pointer structure within the C program. So for example, if its value, index value is 0, and of course you create a new node with this data value is 10, and so this is a new pointer, is pointing to the new node, right? And we don't know where is the it should be on the linked list yet. We create another pointer which points to the first one here initially. It's the top of the linked list, right? Now, because the index value is 0, this loop condition is met, right? I equal to 0, I less than or equal to 0. So the condition is met. So the loop will be executed, right? And so when this loop executes, it assigns the pointer to the next. The pointer is pointing to the first element, pointing to this. The next here, the next is pointing to this element, right? So at the end of this loop will only be run for once, because next time, and I will be 1, so it's going to be, I will be less than, I will be larger than the index, so this condition will not be met. So this loop will only be run once. So at the end of the loop, this predicate pointer is pointing to this value, 17, right? Now, after that, the predicate pointer's next is pointing to the data value 22. And that one is assigned to this new node. The new node's pointing to the next value. The new node is pointing to here, after this one. So after this statement, the new node is pointing to this data element with the value 22. Okay, and the next statement is this one. The predicate pointer next is this one. It was originally pointing to the data value 22, and now it is assigned a new pointer, which means this one is pointing to the data value 10. So the result is this 10 is going to be inserted between 17 and 22. Okay. So if you have any further questions, feel free to let me know. So that's the quick update on the class so far. And so for week 3, one of the topics is called infix, postfix, and prefix. Well, the main motivation of talking about this is it is a very, very good application of the stack data structure we just learned in the previous week. And these are the 3 different format of expressions. Now here is an example of what I mean. Let's say if we want to express this one, A multiplied by B plus C. So this is typically how we write in a program, okay, in a C language, for example. And this is we call infix format. And the postfix format is like this, with the operators behind the operands. So A multiply B, you have to go to the next one to see whether this is A, B is a multiplication or not. And the same, so the operators come after the operands, whereas here, the operators are in between the operands, so it's called an infix. This is postfix, and there is another version called a prefix. The operators are before this operands. Okay. Now, what exactly they mean and what some of the details you will be able, it's one of the things you're going to learn from this module, so the videos and reading materials. Okay. So now, what do you expect to learn? First of all, why are we even doing this? What's the differences between these three different formats? Isn't this format good enough? Right? And of course, there are some differences, and the differences will have key implication on different application. So, for example, if it's a compiler, you will see, right? And one format will be easier for the compiler to process, and so on. And of course, we are, talking about this subject under the context of a stack application. And so what exactly, makes it easier to use a stack to implement this and so on. And of course, you're expected to understand how to convert, from one format to the other. Okay, so that's one topic. And the second topic is a new type of data structure called a queue. Okay, now queue is kind of like an opposite of a stack. A stack is like first in and last out, whereas queue is first in, first out. And similar to stack, there will be operation about moving an element into a queue and removing an element from the queue. That's the basic operation. So why talking about queue data structure? Well, the queue data structure resembles a lot of things in our life. Actually, we spend a lot of time in our life waiting in some kind of queues. For example, waiting in line at a checkout, the stack at stores, various stores, and waiting for a bus, train, and so on. Right? So there are many things in the computer, inside the computer network. When you transmit a packet from one place to the other, you put them into the queue first, if the output is busy, and so on. All kinds of queues that we can apply to. So what do we expect to learn? And so first of all, you need to understand what is the queue class, just like the linked list and stack we learn. And it is, the class means it's the basic data structure as well as a set of basic operation of member functions and their implementation in C++, of course. And secondly, how to implement the queues with basic data structure. We're talking about two types of basic data structure here. One is array and the other is a linked list. So you will learn how to implement a queue data structure using array as well as using linked list and the pros and cons of each implementation. And lastly, you will learn how to use queue data structure to solve some real problems. Okay. So these are the two main subjects, as I mentioned, that in a couple of days, I'm going to make a separate video to go over some of the labs and programming assignment and to help you work on these assignments. Okay. In the meantime, enjoy. Thank you very much.